Hello everyone, in today's lecture we will be completing exercise 4.5. So before completing the remaining questions from 12 to 17, let us see some important points which would be helpful in your MCQ type questions. So the first point is A into adjoint of A is same as adjoint of A into A is equal to determinant of A into I. Second point, AB inverse is same as B inverse into A inverse. Second point, AB inverse is equal to B inverse into A inverse. Students always remember that कि पहले हमको B inverse लिखना है and then you have to write down A inverse. Third point, if A and P are non-singular matrices of the same order. What are non-singular matrices, students? In the last lecture we have seen, if the determinant of A is not equal to 0, then we say that A is a non-singular matrix. So here, if A and B both are non-singular matrices of the same order, then AB and BA are also non-singular matrices of the same order. Okay, तो अगर A and B individually non-singular है, तो after we take the product and the resulting matrix what we get, that would also be non-singular. Point number 4, determinant of AB is determinant of A into determinant of B, where A and B are square matrices of the same order. Fifth point, A into A inverse is same as A inverse into A is equal to I. Sixth point, A transpose का inverse is same as A inverse का transpose. Seventh point, adjoint of A dash is equal to adjoint of A the whole dash. Eighth point, determinant of adjoint of A is determinant A raised to n minus 1, where n is the order of the matrix. Ninth one, determinant of A inverse is same as determinant of A raised to minus 1, which you can say it is 1 upon determinant of A. Okay students, so let's continue with the question number 12 now. Here we have been given matrix A and matrix B of the order 2 by 2. You have to verify that AB inverse is equal to B inverse into A inverse. देखो हमको ये प्रॉपर्टी वेरीफाई करना है, AB inverse is equal to B inverse into A inverse. Now students, if you focus on the left hand side, we first require AB. Okay, तो matrix AB हम लोग पहले find कर लेंगे. So this is matrix A, this is matrix B. Multiplication rule is satisfied and the resulting matrix what you are going to get AB is of the order 2 by 2. So multiplication कर लो, first row first column you get A11, first row second column you get A12, second row first column you get A21 and second row second column you get A22. So this is your matrix AB. Now since we want to find AB inverse, तो students आपको याद है कि A inverse का फॉर्मूला क्या था using adjoint method? A inverse is 1 upon determinant of A into adjoint of A. तो अगर हमको ए बी इनवर्स फाइंड करना है तो फॉर्मूला क्या बनेगा 1 अपॉन डिटर्मिनेंट ऑफ ए बी इंटू एडजॉइंट ऑफ ए बी. सो व्हाट वाज द कंडीशन दैट डिटर्मिनेंट ए बी शुड नॉट बी इक्वल टू 0. ओके, सो हम लोग पहले डिटर्मिनेंट ऑफ ए बी फाइंड कर रहे हैं. ओके, एंड वी आर गेटिंग 4087 माइनस 4089 which comes out to be minus 2 which is not equal to 0. Therefore we can say that AB inverse exists. तो पहले आपको ये प्रूफ करना पड़ेगा कि AB inverse exist करता है. Then we write down the formula for AB inverse, which is 1 upon determinant of A into adjoint of AB. Now determinant of AB we have got minus 2, so we put the value. Students, in the last lecture I have told you how to find adjoint of a 2 by 2 matrix by shortcut method. Okay, तो क्या करेंगे? Once again I recall, we interchange the elements of the principal diagonal. तो 67 और 61 को interchange कर लो and we change the sign of the secondary diagonal. तो इसका साइन चेंज कर लो तो ये माइनस 87 हो जाएगा और इसका साइन चेंज करो तो ये माइनस 47 हो जाएगा. ओके, तो दिस इज योर लेफ्ट हैंड साइड विच इज ए बी इनवर्स. नाउ वी मूव टू द राइट हैंड साइड विच इज बी इनवर्स इनटू ए इनवर्स. तो अगेन बी इनवर्स और ए इनवर्स एग्जिस्ट करना चाहिए. तो दैट इज व्हाई वी फर्स्ट फाइंड डिटर्मिनेंट ऑफ बी, वी फर्स्ट फाइंड डिटर्मिनेंट ऑफ ए एंड प्रूव दैट इट इज नॉट इक्वल टू 0. देन वी कैन से दैट ए इनवर्स एंड बी इनवर्स एग्जिस्ट. ओके, नाउ व्हाट इज द फॉर्मूला फॉर बी इनवर्स? It is 1 upon b into adjoint of AB. Now how to find adjoint of AB? Please tell me. We interchange these two elements. तो यहाँ पे 9 आ जाएगा, यहाँ पे 6 आ जाएगा and we change the sign of these two elements. तो ये minus 8 हो जाएगा और ये minus 7 हो जाएगा. Okay, and determinant of B we have got as minus 2. So this is your B inverse. Okay, now what? A inverse is 1 upon determinant of A into adjoint of A. Determinant of A we have already got 1 and adjoint of A कैसे निकालेंगे? Please tell me what would be the adjoint of A? Interchange the elements. तो इधर आ जाएगा 5, इधर आ जाएगा 3 and this will become minus 7 and this will become minus 2. So that is how you have got adjoint of A and so this is your A inverse. Now we are finding the RHS which is B inverse into A inverse. तो B inverse का वैल्यू लिखा, A inverse का वैल्यू लिखा. Again, matrix multiplication is possible. Resultant matrix we are going to get of the order 2 by 2. So we are doing the multiplication now. The first row, first column if you do, so you get 45 plus 16. Then A12 first row, second column, so you get minus 63 minus 24. Then A21 second row, first column, so minus 35 minus 12. Then A22 second row, second column, so 49 plus 18. So this is your final answer for RHS. So if you now compare equation 1 and equation number 2, both are same. So hence we have verified that AB inverse is equal to B inverse into A inverse. Okay, so now let's move to the question number 13. Again, a matrix A is given to us. You want to show that A square minus 5A plus 7I equal to 0 and hence find A inverse. Now students, ये hence part क्या है वो थोड़ी देर के बाद डिस्कस करता हूँ. First let us prove that A square minus 5A plus 7I equal to 0. तो A square हम लोग पहले find कर लेंगे, which is matrix A into matrix A. Again, matrix multiplication is possible. So net order you are going to get as 2 by 2. So ये multiplication करने के बाद हमको A square ऐसे मिला है. Now we are putting all the values over here. So A square minus 5A plus 7I. Okay, so this is your A square minus 5 times A plus 7 times I means identity matrix of the order 2 by 2. So if you do scalar multiplication over here, तो ये 5 सबके साथ multiply हो जाएगा, यहाँ पे 7 सबके साथ multiply हो जाएगा. So what you are going to get here is 8 minus 15 plus 7. A12 क्या मिलेगा हमको? 5 minus 5 plus 0. A21 minus 5 plus 5 and 0. A22 3 minus 10 plus 7. So if you see here, we are getting a 0 matrix. So you can say that is equal to 0, which is equal to RHS. Now students, यहाँ पे he has used the word hence find. Okay, तो हम लोग A inverse यहाँ पे adjoint method से या row column operation से नहीं find करेंगे. Hence find means very very important. ये जो equation दिया है उसको use करके आपको A inverse find करना है. बहुत सारे स्टूडेंट्स एग्जाम में मिस्टेक करके आते हैं कि हेंस फाइंड ए इनवर्स दिखा तो दे आइदर यूज एडजॉइंट मेथड और दे यूज रो एंड कॉलम ऑपरेशन एंड देन फाइंड ए इनवर्स. आपको मार्क्स नहीं मिलेंगे. ओके, सो लेट अस सी हाउ टू यूज दिस इक्वेशन एंड फाइंड ए इनवर्स. सो व्हाट वी आर गोइंग टू डू हियर इज वी राइट अ गिवन इक्वेशन एज इट इज. ओके, जो हमने प्रूव किया है. नाउ वी राइट समथिंग लाइक दिस, पोस्ट मल्टीप्लाइंग बाय ए इनवर्स ऑन बोथ साइड्स. पोस्ट मीन्स बाद में. ओके, तो हर एक टर्म के बाद में वी आर मल्टीप्लाइंग ए इनवर्स ऑन बोथ द साइड्स. तो now see here, a square को हम लोग क्या लिख सकते हैं? a into a and then I'm multiplying a inverse. Then minus 5a as it is लिखा, उसके बाद जो मैं I'm going to write down a inverse which is in multiplication. Then plus 7i as it is and then into a inverse is equal to right hand side पे भी 0 into a inverse. Now we are using the property that a into a inverse is what? I. तो यहाँ पे a into a inverse क्या हो जाएगा? I. a into a inverse is I. Then I into a inverse is your a inverse. Okay, right hand side remains 0. Now again if you simplify, what is A into I? You get the matrix itself, minus pi I as it is, 7A inverse is equal to 0. Now 7A inverse को एक बाजू रखो and that's why you get pi I minus A. Now 7 if you take on the right hand side, you get A inverse is 1 by 7 of the big bracket 5I minus A. Pi performs scalar multiplication here, so you get 5005 minus the matrix A. Do normal subtraction and that is your answer for A inverse. Okay students, so important thing, please remember, A hence find A inverse बोला है तो don't use A inverse by adjoint method or row column operation. Use the equation and find A inverse. Okay, let's move to the 14th question. Again matrix A is given to us. You want to find the numbers A and B such that this condition is given: A square plus A into capital A plus B into I is equal to 0. So again there is a need to find A square. तो पहले A square find कर लो, A into A. Okay, so 2 by 2 resultant matrix मिल जाएगा हमको. So this is your A square. Now okay, now we proceed with the given condition. A square का value put किया, A into the matrix A plus B into identity matrix of the order 2 by 2. Now perform scalar multiplication and add the matrices. So you get 11 plus 3A plus B. Then A12 क्या मिलेगा हमको? 8 plus 2A plus 0. Then A21 4 plus A plus 0. And then A22 3 plus A plus B is equal to 0 means you can say a 0 matrix of the order 2 by 2. Now by law of equality of matrices you can say that 8 plus 2A equal to 0 and 3 plus A plus B equal to 0. तो इसमें से हमको A का वैल्यू -4 मिल जाएगा and if you put the value of A over here you get B is equal to 1. Okay, so let's proceed with the 15th question. For matrix A, you want to show that a cube minus 6a square plus 5a plus 11i equal to 0. Hence find A inverse. तो स्टूडेंट्स इसके सिमिलर सम हम लोग ने आगे देख चुके हैं. ओके, सो एक्जैक्टली द सेम थिंग वी हैव टू डू. सिर्फ वहाँ पे a स्क्वायर था, यहाँ पे a क्यूब है. तो इफ़ यू रिमेंबर a क्यूब हमको फाइंड करने के लिए फर्स्ट वी नीड टू फाइंड a स्क्वायर. तो a स्क्वायर कैसे फाइंड करेंगे? मैट्रिक्स A इंटू मैट्रिक्स A. ओके, so let us see the multiplication now. A11 we are going to get first row, first column, so we get 1 plus 1 plus 2. A12 first row, second column, so you get 1 plus 2 minus 1. A13 first row, third column, so you get 1 minus 3 plus 3. Then A21 second row, first column, so we get 1 plus 2 minus 6. A22 second row, second column, so 1 plus 4 plus 3. A23 second row, third column, so we get 1 minus 6 minus 9. A31 third row, first column, so 2 minus 1 plus 6. A32 third row, second column, so 2 minus 2 minus 3. And A33 third row, third column, so 2 plus 3 plus 9. So if you simplify, this is your A square. Now how to find A cube? It is A square into A. तो यहाँ पे A square का value put करो and this is your matrix A. Again, if you perform matrix multiplication, you are going to get this as your answer. Okay, so we have got A square, we have got A cube. Now we can put the values in the given equation. So A cube minus 6A square plus 5i plus 11i, you want to prove that it is a zero matrix. A cube का value लिखा, minus 6 into A square value we have put, plus 5 into the matrix A, plus 11 into identity matrix of the order 3 by 3. Now this will perform scalar multiplication. Okay, so what is A11 we are going to get? 8 minus 24 plus 5 plus 11. Likewise A12 क्या मिलेगा हमको? 7 minus 12 plus 5 plus 0. A13 क्या मिलेगा हमको? 1 minus 6 plus 5 plus 0 and so on. You can find the remaining elements, and what do we observe is that students, we are getting a zero matrix, which is your RHS. So we have finished the first part of the question. Now going to finding hence find A inverse. Okay, hence means students हमको equation use करके A inverse find करना है. Okay, so again the method remains same. We write a given equation, then what do we say? Post multiplying by A inverse on both sides. Post means बाद में. Okay, तो A cube को पहले क्या लिख देंगे? A square into A, and then we multiply A inverse, and then A square को we'll write minus 6 into A into A, and then we write A inverse. Then 5 into A into A inverse plus 11 into I into A inverse is equal to 0 into A inverse. Now since A into A inverse क्या होता है? I. So this is going to become I, this is going to become I, this is going to become I, and I into A inverse is A inverse. Okay, so A square into I remains A square. AI is same as A. 5i remains as it is. 11A inverse is equal to 0. So if you simplify the equation, 11A inverse को यहाँ पे रखो, बाकी सारे टर्म्स को राइट हैंड साइड पे शिफ्ट कर दो. Okay, so A inverse is 1 upon 11 into 6A minus A square minus 5 into A. यहाँ पे 6 multiplies with all the elements, 5 multiplies with all the elements, so you get these three matrices. Okay, and then we do normal subtraction of matrices, and this is what you get your final answer. Okay students, simple. Now question number 16. Again we have matrix A is given to us. You want to verify one equation, that A cube minus 6A square plus 9A minus 4I equal to 0. Hence find A inverse. Students, it is exactly similar like the previous question. Okay, I hope you can try this on your own. Please pause the video and do it on your own. Okay dear students, the solution is in front of you. Please verify your answer. So is this your answer for A inverse? Please check कर लेना. I am confident that you might have got the answer. Very nice. Let's proceed to question number 17. Okay, so 17 and 18 are both MCQ type question. So let A be a non-singular square matrix of the order 3 by 3. Then determinant of adjoint of A is equal to. Now students, at the starting of the lecture, we have studied one property that determinant of adjoint of A is what? Determinant of A raised to n minus 1. Where what is n? It is the order of the matrix. So यहाँ पे order क्या दिया हुआ है? 3 by 3. So you can take n is equal to 3. So if you put the value of n as 3 over here, so you get 3 minus 1, which is 2. So determinant of A, the whole square. So your option is number B. Okay, moving to question number 18. If A is a invertible matrix of the order 2 by 2, then determinant of A inverse is what? Determinant of A inverse. So determinant of A inverse we can write like this. Determinant of A inverse. Okay, again we have seen one property that determinant of A inverse is equal to determinant of A raised to minus 1. Okay, so which can be further written as 1 upon determinant of A, which you can also say it is 1 upon det of A. So again it is your option number B. Okay students, I hope you have understood exercise 4.5 very nicely. In the next lecture, we continue with exercise 4.6. Please subscribe my channel in case you have not. Till then, take care and goodbye.